All right, cool. All right. Hello, guys. I'm Alex. This is my first year at DEF CON and also my first time talking about Nix, so I'm a little nervous, so if I stumble a little bit, bear with me. And my talk is 0 to Infra in 100 days, a Nix speedrun. And I'm going to start with a little story about how I got into it and then kind of go through this crash course. And it's funny because Fareed is actually the one that got me into it. I met him at his younger brother's wedding. Omar, he's one of my best friends. And he said, you should come with me to PlanetNix at scale 22x. And I was like, I don't know what that is, but I like Linux and I'm a nerd and I have all my home lab stuff, so I'll just go and try it. And I was there. I set up a laptop in 4 days trying to learn Nix. Looking back, I didn't really have it, but I met a bunch of really smart people and I learned a ton of stuff and it was really awesome. And I'm just super Nix pilled now, so I'm gonna try to get you to be the same way maybe. So I'm gonna get into it. My talk is pretty similar to Fareed's in terms of the beginner level. Mine's gonna also kind of be a crash course, but I'm gonna say mine's gonna be even less academic. I'm gonna try to give you what you need to know to get started as soon as possible without knowing all the theory behind it. And you can kind of pick that up as you go once you see the power and you start using it. So in most of these talks, people are always gonna open with what is Nix? And I think that is not the right question. I think why Nix and showing what it is and how it works for you is more powerful. Because when people open with these talks, they'll say, Nix is a package manager, a language, and an operating system. And when you say that, it just turns everyone off immediately. That's three different things. That's like saying C, Ubuntu, and APT. That's what the hell. So basically, but with Nix, why Nix? It simplifies what you can get out of everything. So in a traditional sense, I'm gonna use kitchen recipes analogies a lot. At PlanetNix, somebody made that analogy and I really liked it. It clicked for me a lot. So the traditional is if I'm making a tomato sauce, the traditional way would be I gotta add tomatoes, and that's all I'm gonna say. But the Nix sauce is gonna say, I'm gonna add tomatoes from this farm at this acidity, stored at this ripeness level. And it's gonna give you the precise same outputs every time because you are gonna give it the same inputs every time. And actually, I guess, so I also made myself a little cheat sheet here so I don't mess up running any commands and stuff. And my talk's just I'm gonna run a lot of stuff live and just show you rather than talking about it. So just to show you some of the really cool stuff that Nix can do to kind of get you hooked, I'm gonna talk about Nix shell. So what I'm gonna do is something that probably isn't normally allowed, where I'm gonna make an environment with Python 2 and 3 at the same time. And when I run this, it's actually gonna throw a fit. And that's good because it's actually Nix protecting us. It's saying, Python 2 isn't actually marked as secure anymore. And we can just get by this by allowing to run insecure. But what it's gonna do is it's gonna put me into a shell. So this is my own little environment. And Free talked about this a little bit where it's just referencing store paths, and I'll talk more about that in a second, but it's just making path variables for your shell. So I can run, and you can see I have Python 2.7, and I can also do the same command for Python 3. I have 2 and 3 in the same shell. I can use either one if I want. So that's pretty cool. And then a couple more. You can run things that are packaged by others and put up without actually having it on your system. And this is super useful. I use this all the time through a different command like comma. You showed me that too. So just as an example of that, I don't have this. This is a little 2E terminal game, 2048 in terminal. I don't have it, but I can just run it. I can Nix run, and what it's going to do is it's going to grab it from the magic world, and it's going to just run it on my machine. I don't have it on my machine, but now I have it on my machine, and now I'm playing this game. So that's kind of why use Nix. So those are a couple examples of what it is, how you can use it, why you should care a little bit. And now this is the whole funny thing, why does Nix seem to have such an infamous learning curve? So this is the graph that I found on one of the most popular discourse pages for this is one of the best lectures about Nix, and it was a 30-minute dense lecture about using the language. And that one of the people commented this on it, and I think that makes sense. It's like, the learning curve is infamously super steep and treacherous, and I don't think it has to be that way. I don't think you actually need to learn all the theory right now. I think all you need to know is just a couple commands I'll show you and the environment. So Nix run, Nix develop, and how to yoink other people's shit. That's all you need to know. You can be productive today using it. You don't need to know, like you can say that's a car, you don't need to know about how to put the engine together inside of it yet. You'll probably be interested and want to learn about that later. I will get into some of the inner workings because I think it's important for you to have a baseline understanding of how it works, so you're not just looking in this magical wizard orb and not knowing how the magic works. But as a general guideline for all of it, don't fight immutability. This was the biggest rule for me to like start using Nix without fighting myself on it. So one of the first mistakes I made was I needed to make an alias in my shell, and I set my shell up with Nix, right? So I build it and it gets put on my machine in the state that it is, and I went into my ZSHRC and I added the alias, and it worked for a while, but the next time I rebuilt, it was gone because it rebuilds it every time. So you're not opening settings menus and trying to find the setting and setting it there. You're gonna go into the configuration file for it, you're gonna set the option there and just rebuild to a state where that is the state of things. You'll avoid most of the roadblocks, I think, just getting started immediately with a Nix system just by following this rule. Just don't fight immutability. Keep in mind, like, I'm not following steps. And this gets into the whole notion of imperative versus declarative, which I'm gonna get into, like, what the heck does that even mean? But like manually going and doing a setting would be something that's imperative, and just doing it in your configuration and then rebuilding, that's gonna be declarative. So declarative versus imperative, like what the heck does this even mean? So this is like the Wikipedia definition for it. I'm not gonna read it because this is like my crash course talk, like who cares? This is my analogy. For imperative, I want a sandwich. Do I order it? Do I make it? I need to do X, Y, Z to get my sandwich somehow. Okay, I'm gonna make it. I'm gonna get the bread, I'm gonna put the meat on it, mustard, mayo, blah, blah, blah. I did all these things and now I got my sandwich. So in a declarative approach, all I do is I want a sandwich, I declare I have a sandwich, and now I just have a sandwich. All the stuff to get to the sandwich, I don't care about. Nix can do that for me. Nix can be my sandwich guy. But me, I have the sandwich now. I declare I have it, so now I have it. That's my analogy, and this is like with the whole food thing I'm gonna keep going into more. Yeah. So this is like an example of setting up a web server imperatively. You got to run a crap load of commands. You're running curl commands. You're adding PPAs. You got to add systemd services. You got to add a user for it. You're running all these commands one at a time, one after the other. If one of those links is broken, like stuff's busted, and then by the end of it, like what did you even install? Like, can you do this again? Like, you can make a script, but what if something else is broken? And this is like this is the point of it. Do you even know all the stuff on your system, on your computer? Do you actually know all the stuff installed on your computer right now? I bet you don't. Like, unless you use Nix, then you do. But like, you just, like, it's following like a Medium article to set something up. You copy a link and you run some curl command and it puts something on your computer. 2 months later, you don't even remember doing that. It's on there somewhere. Maybe you're like refreshing your repository with it. You have no idea. The declarative approach to this is the same thing set up with Nix, and I'm going to break this down a little bit in a second, but you're declaring each service, and this is going to give you the same results every time, no matter what. And we're doing everything from setting up the services like Nginx, PostgreSQL, and the systemd service, and even setting up the user to run this. And so when I look at this can be kind of like intimidating to look at it first. There's a lot of brackets, and this is how I look at it. I break it down. I did my scribble. Just look for the like top level attributes, the curlies, and when you actually look inside each of them as like a chunk, it actually makes it a lot easier to understand what's even going on. So like, just look at the first one. It's a service, Nginx, we're enabling it, and then we're just doing settings for that specifically. Same thing for the other ones. The systemd one, that's the same syntax you're writing to like write your own systemd service. You're just doing it through Nix, and it's going to end up on your system after you rebuild it. Even the same thing with the user. I'm making a user called my app. So Dev shells and derenv are your gateway drug into getting into Nix, and if you take nothing else away from this talk, it's just start using dev shells to do development of whatever you're working on. It makes stuff super easy, and it makes collaborating with other people really, really easy too. Your directory becomes your full custom environment. So just to show this, and this is all the stuff you need to do a derenv and dev shell. You need the envrc, which is for derenv, and flakes, which I'll get into a little bit later. But just as a top level, that's just the thing packaged reproducibly monolith. And so just to show this, I did a web server in Rust, super simple. And I'm going to show, like this is the flake, the whole thing. And like this kind of ties into yoinking other people's stuff. Like you can yoink this and just replace it with the stuff that you need for your project. But all I'm doing is like I need Rust C, I need cargo, I need Rust analyzer, and then I'm spitting this stuff out when I enter it. And I have the inputs. And you'll see, like, once I enter the shell, you see all this stuff. Like I loaded the flake, and then it spits that stuff out that was inside the flake. So if I exit now, if I go out of this, you see it says unloading. If I run Rust C, I don't have it. It's not on my system. But as soon as I just enter that dev shell, I have Rust C now magically. Just I'm inside of this new environment. And the same thing, I can just do cargo run. All my stuff was together, and now I have this little private web page. Hello from Nix. It just works. I have it on the dev shell. And for a lot of the projects that I've been working on, I've repackaged them to use dev shells, and it makes sharing the setup super easy. Like if you're trying to collaborate on something with someone, they can clone your project, and then they just enter the dev shell as long as they have Nix on their system, and they have the exact same environment that you have for working on something. It makes it really easy to like have the same stuff on all the machines for your whole team all working on the same stuff. Okay, so now is my slightly dense part of this like lecture part. This is my speedrun lecture. How does this stuff actually work? I think it's important for you to have some base knowledge of what's going on under the hood, so it doesn't all seem like some mystical orb that you're pondering. You're like a wizard. So I think all you really need to know to get jump started and feel not confused by what you're doing every day is derivations, what's the store, what is Nix packages, and what are flakes. And I'm going to go through like a blitz explanation of all of these, and I'm going to give some examples as I go. So basically, and this goes back to my food thing, derivation is how stuff gets built. A derivation is a recipe to do something. For example, let's do the GNU Hello program. All it does is just print out hello world. And this is the stuff that's inside of that derivation. It's going to say, I need this hello tar.gz source code stuff, I need GCC, and I need make. And these are the recipe inputs. And if I do this, if I put all these together, I'm going to get this same output every time. And just to show this, this is what a derivation actually looks like. We showed this a little bit earlier, but so you don't actually need to read too far into it. It looks like JSON. It is JSON, and you can see it's spitting out the hash stuff and the output where it's going to end up on the machine. But this is what's inside of it. It's not scary. It's just JSON. It's showing all the inputs. Like you can see, like these are the inputs. This is how it's being built. These are all like the flags for, like you see CMake flags, like for make stuff. That's how it is. And just to show a little bit more about this hash thing at the bottom, just so you know like what this is, that's basically the result of all the inputs in the derivation getting spit out somewhere, and that'll tell you that it's the same thing every time based on the inputs. That's how we make sure that all the stuff that we're putting in is the exact same every time, so that we get that reproducibility. And so just to show this, if we do that same thing, make note of the hash thing. If I do this command, all I'm doing here is I'm going to show this derivation again, but I'm just going to add a random variable to it, just called myvar equals demo. It doesn't do anything, doesn't change anything, but the fact that I added it and the fact that it's there in the inputs, it changes the output. It changes the hash, even though, and like we can see it in the inputs here. It's here, doesn't do anything, but the end result, this GJI, whatever, and then down here, it's different. The end result is different because of what we put in, even though it's not actually doing anything. And Nix is very picky about everything that you put into it, and that guarantees that even if you change like a comment, the entire thing's going to be different in the end. And just to show like what is this hash, where does it come from, I have this. I have like this file.txt. This is a test file, capital T, exclamation point, just like make note of that, right? If I do nix hash file.txt, it's going to give me the hash for the file because like of the stuff in it. If I go back into that file and I change something, I'm just going to like, there, just one thing. If I run that same thing, my hash is different because I changed the contents of the file. So that's all that a hash is. It's just making sure that your inputs are the same. So next is the Nix store. This is where everything lives. This is like the pantry in your house for all the stuff. This is like an excerpt of what all the stuff looks like in the Nix store. I highlighted all the hashes just so you can kind of like separate out like what the thing is and then the hash. And the binary cache, I think that's something important to know about as well. You can think of that as pre-cooked meals. And when I go to, I think I have this. Yeah, I'm gonna get into it here as well. But when I go to grab something, I'm going to get the derivation from somewhere, which I'll talk about in a second. And I'm storing that, and the final binary, all of that's being put into the store. And when I go to actually decide whether or not I need to build something from the derivation, you can actually skip that whole step, because if we know the hash is the exact same, we know all the inputs are the same, so we know the result is going to be what we want. So if somebody else already built that for us and they put it somewhere that we can grab easily, why would we do the whole process of rebuilding it all ourselves? So that's all a binary cache. It's just pre-cooked meals for you to fetch. No need to manually rebuild stuff. So this slide is like my densest one. I was thinking about what the best way to explain this is, but Nix packages you can think of as where all these recipes come from. It's the biggest, fattest cookbook. And this search.nixos.org, you can go here, you can do a search for any Nix package you could probably possibly think of, and it's probably there. Somebody's probably packaged it and put it there. It is absolutely huge. And it's like all the secret sauce. It has so many recipe generators. Before I had this slide saying recipes themselves, but I think saying that is a little bit too much of an oversimplification. So here's the flow of what happens when we run like that command to run the hello program, or the one where I did 2048. When you run it, Nix is going to look up hello in Nix packages, which is your big cookbook. It's going to look in the cookbook for the hello. And the cookbook has a recipe generator. You can think of this as like a template for the recipe. And it's not the recipe itself. So your machine's going to get the recipe from the cookbook on its own. Nix is going to run the recipe generator to get the actual recipe, the derivation for your system. And then it's going to ask the binary cache, yo, do you have this thing? And if you have it, sweet, I don't have to build it myself. Yoink, I'm going to grab it. And if not, I'm going to build it myself. And this process of building it yourself, like let's say for this hello, it didn't have it. Let's say I needed like GCC to do it, which we do. It's going to turtle all the way down recursively and go all the way down to the bootstrap layer if it has to, if it can't find stuff in the binary cache, which is really cool because that means like you can build up anything from the lowest level possible, which would take forever, but you could. You don't need external sources to build. All you need is the very bare minimum, which is like POSIX shell and like bash and like C compiler, stuff like that, super minimal. And at the end, it puts all this stuff in the store. And it puts both the recipe, the derivation, and the final binary in the store. It puts both of those in the store together. Not under the same hash, they're separate. So yeah, so that's Nix packages. So just to recap super fast, derivations are recipes, the Nix store is your pantry, Nix packages is the biggest, fattest cookbook, and I kind of went on a little bit of a side tangent about these recipe generator things, just to not confuse you later if you look into it more. And this is just a graph that shows all the, it might be kind of hard to see, but it shows all the like repositories. And you can see that Nix packages unstable is just completely in a league of its own, all the way up at the top. Like the AUR is a little bit underneath it, but those different versions get into what we're going to talk about next for Nix packages. So flakes. Flakes is the reproducibility solution. Explaining flakes can be pretty difficult, but just use flakes, bro. Trust me. Just trust me, bro. All the cool kids use flakes. In order to explain flakes, I'm going to talk about channels really quickly. And I think you need to know about that to understand what flakes is doing and why you should care. So earlier when I gave you this example for building the hello binary, I showed you these are the inputs, and I lied to you. I'm sorry. There's actually a hidden input, and it's the Nix packages version that you're grabbing the stuff from. And that actually changes the output because the inputs are different. So just to show this, I'm going to run evaluate, which is just going to do the, it's going to tell me what I'm going to get. It's not going to do the build for me. It's going to tell me what the result would be. And you're going to see I have this hash here. Really only look at like the last couple characters just to pay attention. And I'm going to do the same thing, but this time I'm going to specify I want it from Nix packages version 2505. And I think my system right now is on 2511 or unstable. But you'll see if I run it, my hash is different. And why? It's actually a different version of this hello program. So if I run this just to show, this one's 2.12.2. If I run the same thing, this one's 2.12.1. I actually think I have a different version in that example. I can change this to 2505. Busy, start again. 2.12.1, same thing. But the versions are different. So on my system, the one that I have currently, when I ran that evaluate, I got 2.12.2, and the hash was different versus what it is if I used some different version. So that gets back to the whole, it's different. So running different versions of stuff for the same build will give you a different result. So this is kind of where Flakes comes in. And what it does is it's pinning of Nix packages. And this is like the reproducibility solution monolith all in one. So it goes back to the highest level of the same inputs are always going to give you the same outputs. And now it's the same inputs for real. It's using all the same Nix package source, and you can pin versions for specific packages. Once I run this, like this is just a super quick example of that hello in there, super minimal. I'm just pinning it to version 2311 for Nix packages in this example, and it's going to generate me a lock file, which is how they version everything, and it's going to keep track of the version of all the packages, so that if I give you my repo or whatever, and you run it with the flake in it, you're going to get the exact same output every time. Because the version, the Nix packages version for every package you're using is going to also be the same. There's no more invariability between our systems. What if your system is running 2511 and mine's 2505? Now we get a different result. This is not the reproducibility that we actually wanted. So this is like the highest level. Let's take this to the next level, NixOS. This is all the previous stuff we talked about, but instead of configuring applications, packages, you're doing it for your system now. And this you can do this for your bootloader, login manager, blah, 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 all the stuff for your system, which is, it's pretty crazy when you think about it. You can do your entire system configured declaratively, and you can just share your entire computer configuration with somebody else, and they can just have your whole setup, which is what I did earlier. I put my laptop right here, my whole configuration, onto my brother's laptop. I did that 2 days ago. And just to show this, I'm going to give a quick example. And all that I have here is just a flake, and it is using Astro's micro VMs, which is just I'm just going to boot up a micro VM to show you a NixOS system. And I'm sharing my Nix store with it so that the boot up time is really fast. But this is the whole flake. It's really simple. All I'm doing is I'm pulling in Nix packages. I'm using unstable, and I'm using microvm, which is the thing I just told you about. And this is the configuration for it. The stuff that you care about is this configuration.nix file that I made to make it easier to follow. This is what it looks like. I'm setting up the host name for my system. I'm making a user, demo user. I'm giving him a password, a description. He's a normal user, and I'm giving him wheel group so he can run sudo. And he's got these packages for the system. He's got the whole system. It has Vim on it, and it's going to auto log in for my demo user, and I'm pinning the system state version. So if I just run this, you're going to see it's going to boot up a microvm. And it's going to put that stuff from the configuration on this machine. And you'll see we're going to be logged in as demo user in a second. And we'll see we have the Vim package on here. So we're logged in. Cool. Who am I? Groups. Users wheel. Cool. Vim. Do I have it? I do have it. And then can I run sudo? Power off. Password was demo. Yeah, I can shut it down. Just to show this like super quick, what I'm just going to do is I'm going to add htop to the packages that are going to go on the system, and I'm going to build it again, and you're going to see that this time I'm going to have, I probably should have shown that I didn't have htop on it before, but trust me, I didn't. I'm running it again, and you'll see that we have that package on the machine now. And this little microvm is just a super simplification of a bigger NixOS system that has all this stuff on it. So like this system that I'm showing you this on right now has that. Cool, we have it. So yeah, it's really powerful being able to use Nix for a whole system instead of just packages and configurations. And it lets you be really particular about everything that you have on that given system. And it lets you track it all super easily because like you can just go to that configuration file and see what's on the system. There's no ambiguity about what's installed on there or how things are configured. And just as a quick aside, generations. So I noticed somebody said a question about like versioning systems before, and I added that while I was listening. Generations are really cool for this system. If I had this on a traditional system and I like rebooted my machine right now, during my boot menu, I have the option to roll back or use a different generation or version of my NixOS configuration. So every time I make a change to my config and I rebuild my system to it, it's going to add it as a new generation list, and it keeps a backlog of however many you can specify how many you want to keep, how many you want to like delete after a certain portion of time. But if I'm doing this and I add some bad config, like I do something dangerous, like I change variables for my bootloader, like I'm configuring it with Nix, and I do something bad and I bork it. And now my system is broken and I don't even boot. It's fine, I'll just roll back a configuration and I'm saved. You don't have to worry about breaking your system anymore. You can go ham and do all the stupid things you want to do and not have to worry about doing the full fresh install all the way from scratch. So yeah, thanks. That was kind of like my super crash course about how I went from not really knowing anything about Nix just back in February to now I have all my machines configured declaratively. I get to hack on Nix for work, and yeah, and I guess at this point, to fill extra time if I have it, I'm just gonna kind of flex my repository that I have for like my machines, and I share it with written over there. So I'll show you. So yeah, this is ours, and the way, without getting too much into it, just to show, not everything for a system configuration has to be all condensed into one file, because most people don't actually do that because it would end up being really huge. They split it out into multiple things, and just at the end, it all gets merged together back into the same place. But the way that I have things set up, that I think is really cool for organizations is, and I'm only going to show this part, I think, the way that I have machines, users, and user environments configured across all my machines all in one place. So I have all these machines set up on our infrastructure. So like Alex Dev is a machine, Alex Framework, that's this machine, this laptop that I'm using right now. And I put the name for it, the host, the target host for it, and this is using clan, by the way. I should have mentioned that. And I have this tag system set up so that I don't actually have all the configurations all in one big place like I mentioned. It's actually kind of like a buffet example where you go to this inventory and you pick out the things that you want for that machine. So this is a laptop, I want to be on Tailnet, and this laptop has Hyperland on it. That's what I want. And if I go and actually look at those tags, like for the Hyperland one, you can see like for this is the base stuff that I need to do Hyperland. So this, because I added this tag to that machine, this is getting pulled into and essentially added to, as far as that machine is concerned, this is part of its configuration. And the next step is like Home Manager, which is configuring dot files for yourself. So like, for instance, this is my ZSH RC setup with Home Manager, which is basically, Home Manager is Nix setup, but for your dot files to manage all of that declaratively as well. And the end result of this, so I have all this stuff on here, I'll show you, like we have all these aliases and stuff, and what I'll do is, like this is the generated ZSH RC. This is like some robot generated RC. You probably wouldn't want to read this, like it's not meant to be superhuman readable. But you can see like it's taking all the stuff that I'm configuring here and it's putting it all in here. Like all the aliases are here from everywhere. But yeah, so the end game I guess that I'm getting at with this is you can be really modular with system configurations and you can manage all your machines from the same place and choose what you want to be on them with these like pre-built little like nuggets that you can make for it. And it makes spinning up new machines and managing machines and knowing the exact state of all your machines super easy. So yeah, I think that's about it. So thanks guys.